Students, in the last lecture we have seen about the pair of lines and that equation of the pair of lines, that is combined equation of the pair of lines. Now in this lecture we start with the separate equation of lines that is obtained from the combined equation of the lines. So how can you obtain the separate equations of the lines? So it is a very easy method, but sometimes some difficulties occur there. So here combined equation gives us separate equation of lines, that is u is equal to and v, u is equal to 0 and v is equal to 0 by simply factorization method. But sometimes this factorization methods, that is simple method, that is fails, and in that case you have to use the another method to obtain the separate equations. So sometimes this combined equation is not factorizable. This equation is not factorizable, and in such case auxiliary equation of the given combined equation to be obtained. And what is this auxiliary equation? That is to be remembered very well, because it is a quadratic equation in M, means you have to factorize the quadratic equation. So you must remember that if the factors are not possible, in that case you have to use this auxiliary equation, that is given by bm square plus twice hm plus a is equal to 0. So this is called the auxiliary equation. It is to be considered, which gives the two values of slope, that is m, and that is written as m1 and m2. As you want the separate equation from the pair in terms of pair, we need the two values of the slopes that is obtained from this auxiliary equation. Then using the equation y is equal to mx, this is the equation of the line passing through the origin, and we get the separate equation of the lines putting different values of m here, that is y is equal to m1x and y is equal to m2x. So in this way the given equation is not factorizable, then the auxiliary equation to be used. Then again we need the certain terms here, that is sum of the slopes, that is m1 plus m2. If ax square plus twice hxy plus by square is equal to 0 represent the combined equation of the lines, then sum of the slopes, that is given by m1 plus m2 is equal to minus twice h by b, where b is the coefficient of y square, twice h is the coefficient of xy. So here sum of the slopes, that is the formula to be obtained here, m1 plus m2 is equal to minus twice h by b. Similarly, product of the slopes, we need also the product of the slopes, that is m1 into m2 is equal to a by b, where a is the coefficient of x square and b is the coefficient of y square. So these are the terms, sum of the slope, product of the slopes, then auxiliary equations if the given combined equation is not factorizable. These are the terms required in the problems. Again we come to the conditions here. There are certain conditions applied on the lines, pair of lines, distinct lines. When do you say that the given equation represent the pair of distinct lines? So here condition is given, h square minus ab is greater than 0. The lines are distinct, means they are separate lines, they are not combined parallel or they are called coinciding lines. They are separate lines, means distinct lines. Second condition, s square minus ab is equal to 0. Lines are coincident. Sometimes we say that that is parallel lines also. So sometimes it is asked that find the condition whether the given equation represent the equation of parallel lines or coincident lines. So your s square minus ab should be 0. And then third condition is that s square minus ab is less than 0. The lines are imaginary. Imaginary means we cannot imagine these lines because these lines are not in existence. We can't show these lines on the blackboard, and therefore these lines are imaginary. The condition is that s square minus ab is less than 0. Then we come to the particular problem of these separate equations of the lines. So we take the example here. Find the separate equation of the lines. Here x square minus 4y square is equal to 0. Always this equation to be compared with the combined equation of the lines, that is the ax square plus twice hxy plus by square is equal to 0. So in this equation h term is absent, but term in x square and term in y square absent, mean definitely it is a combined equation of the pair of lines. Now we try to separate them. We want to find out the separate equations of the lines. So we have seen there, if the equation is simplified by simple factorization method, and if it is not simplified, then we use the auxiliary equation. So we try to simplify this equation. So given equation of the lines, x square minus 4y square is equal to 0. So it is x square minus 4 can be written as 2y whole square, means it is square term. So it is x minus 2y whole square, and we know the formula, a square minus b square is equal to a minus b into a plus b. These are the factors of this term. So now we compare this, your a is x and your b is twice y. So it is easily factorizable by this standard formula, a square minus b square is equal to a minus b into a plus b. So here it is a is x, b is twice y, so it is x minus twice y in the first bracket as per this formula, and in the second bracket a is x plus b is twice y, so x plus twice y is equal to 0, and that is we separate them. First x minus twice y is equal to 0 or x plus twice y is equal to 0. These are the required separate equations of the lines. So this is very easy method of the simplification, which gives the separate equations of the lines from the combined equation of the lines. Then we come to the second problem. Show that the lines represented by equation x square minus twice xy minus thrice y square is equal to 0 are distinct. Means you want to apply this condition. What is the condition for the distinct lines? S square minus ab is greater than 0, and that gives us lines are distinct lines. Whether this condition is satisfied here or not, that we compare the given equation with the general equation. So x square minus twice xy minus 3y square gives us a pair of lines, combined equation of a pair of lines, and it is compared with ax square plus twice hxy plus by square is equal to 0. So comparing this, x square has the coefficient 1 and here x square has coefficient a, therefore a is equal to 1. Then y square coefficient is minus 3, here y square coefficient is b, therefore b is equal to minus 3. Then twice h is equal to 2, therefore h is equal to twice h is equal to minus 2, this is minus 2, and therefore h is equal to minus 1. So thus we got here values value of a, value of b, and value of h, that we apply the condition, that is h square minus ab equal to h is equal to minus 1 whole square minus a is 1, b is minus 3. So minus 1 square is 1 plus minus 1 into minus 3 is minus that is plus 3, that is 1 plus 3 is 4, and this gives us 4 is greater than 0. Means what do we get here? A square minus ab is greater than 0, means this condition S square minus AB greater than 0, this condition is satisfied here, and therefore definitely we can say that the lines are distinct, and therefore hence the lines are distinct lines. So in this way we can apply the different conditions to show that whether the lines are distinct or the coinciding or the imaginary. So in the next lecture we start with more examples. Thank you.